Thank you very much for coming in today, this morning, a very beautiful time, 10 in the morning. As she introduced me already, my name is Astrid. I'm the founder and CEO of Twindly. You could just hold here. And he is my co-founder and CTO of Twindly, and we're both going to talk a little bit about how we use Google Cloud infrastructure, Twindly. So we're going to take you out on a journey today, and because we started using cloud like 8 months ago or something. So we're going to start. And before we actually go to the slides, I would like to know a little bit more about you. So are you building, how many of you are in your own startup or doing a startup project? Okay, cool. Are you familiar with Google Cloud? Have you deployed something, already done something in the cloud? Okay, cool. Few of you, okay. So I'm a little glad about that because although we are both developers, we're not really adept in, we started, as I said, we started like 8 months ago doing Google Cloud, so we're kind of new, and we wanted to do this because we have a dream of building our platform. What is actually our dream? So Twindly, the platform we're building, is a web application for beauty geeks to find their beauty twins and to discover products and looks. I would imagine, like you probably get a little lost in beauty. I see. But it's, I'm happy to see a few women here, 1, 2, including me, but I think yeah. So the platform itself is for beauty, and maybe even though you're not a user, but if you go to Douglas and all the makeup shop, you see that we have a huge array of products. So, but basically what we want to build is, there's 3 main components in our system that we want it to be social, which connects the beauty geek to another beauty geek. In this case, it's like, like you see these 2 people kind of similar in their appearance, and they probably want to be connected with each other, and then we try to find a system, or try to build a system that connects the twins. So the second part is connecting the geeks to the products. As you see, there's a lot of shades of red, and I could attest to you that every red looks different on your skin. So we want to make the connection between like what kind of products you like, what kind of color and lipstick, eyeshadow, and all that. And then the most important thing that we want to build is the recommendation. So if you would imagine your face is like a blank canvas, we basically want to show you and kind of like which one suits you best. Like there's the classic look of Nefertiti, and there's a modern look. Like if you want to go out on like a 90s party or very strong bold color, then you would probably pick out the one on the right hand side. But if you go for classic looks, and it's on the left hand side, and it's not like one is better than the other, but it's always like based on what you actually like and based on what the situation that you would like to go to. So just a little bit, and then like, who are we actually? That's a big tall order, and we are 2 developers doing this. Yeah, that's me. I'm Dev 1, and Abi is the Dev 2, and Abi is actually still have a full-time job, so he does this part-time. I'm doing this full time, but I'm also handling like business and marketing. So basically, we have to do it like kind of try to be as easy as possible. Not so you can't like spend 80-hour week on it, but we still somehow managed to build the system. This is what we thought as the skill set that we would need to build Twindly. See, there's quite a lot, and I cover UI and UX because I'm a designer as well, and we both know a bit more or less about front-end dev. I mean, I know HTML, CSS, and Bootstrap, and Abi is like an excellent front-end dev and JavaScript. Yeah, Abi knows most about back-end dev and doing Node.JS most of the time. We know database, MySQL, MongoDB, and I'm just getting into Neo4j Graph. I know about machine learning and recommender. But yeah, that's the thing, like neither of us actually know anything about DevOps. And it's quite important if you actually want to build this kind of system. The last part, like mobile, yeah, because now all the the future is in mobile. So although currently it's still just a responsive web, but we know a bit more about like, yeah, Abi knows about Android, I know a bit more about iOS, and what we know like web responsive. So taking off on this journey, like what can we actually build for this? Because we have that scale in such system. So naturally we start pre-cloud and going with something that we're both comfortable in. We build the stack. We built a LAMP stack, of course. So we take a server. We were looking for like an open source social network that we can play around, and we have a look at Elk to start with, and Elk is in PHP, and we use a MySQL database, hoping that at least we could go to the next slide. Yeah. It will be quicker for us to prototype, and it's on a familiar stack from us that we know. But then as we tried more and more, we realized, okay, first it doesn't have a recommendation implementation, or you need really to install something extra on top of that. And then we have a bit more scaling problem, and as we tried Elk, we realized it takes a long time for us to also modify it the way we want our social network to work. So we thought, okay, if we need to build a new one again later on, maybe we try something else. And as Abi started doing more and more work in Node.js, we realized maybe we should try Node.js, and we start looking into cloud and checked out Heroku. But unfortunately, so Heroku didn't support Asian region. I think they still didn't until now. I mean, at least last time I checked, they didn't. And because we are both Indonesian, and we wanted to have Twindly also working in Asia, or have an Asian instance, and I think that was important for us. And then we come across Google Cloud a year ago. I think they have an event in November or October last year. There are a few things that I was really interested in, because first of all, it seems, I mean, they do have an Asian instance, and then they do offer quite generous try-out package for a developer. I mean, they offer like, I think now like $200, $300 or $500 even, yeah. But one thing that really stood out to me was this. When I was there, they said like, okay, it's easy to auto scale the DevOps of the server. So we thought, oh, cool, like no DevOps, no problem. So maybe we will give it a try then. Yeah, and So here comes the story of how we did it, and Abhi will continue on with that.
Okay, thanks. So how do you start doing cloud? So you start doing cloud by start doing it. So AppEngine is the one that how we start doing cloud. So how many guys are familiar or knows about Google App Engine? Okay, so AppEngine is platform as a service from Google. So the idea is that you can focus more on building your web services, and Google will host and scale it automatically for you. So if you build your application, you're using AppEngine SDK, so you can pick from Java, PHP, Python, and Go. So these are the famous language that they support back then. I'm a Node.JS developer, so I wish there's a JavaScript there, but we have to pick one of this. So we tried Python. So you start with the tutorial, how to do that. It's really easy to start with. So you can try the tutorial directly on their website. And we have a look and whether we want to use Python or maybe Go. And after a while, we try this and that. I check the meetups about the speed of Go, and I'm pretty sold about Go. So we decide to go with Go. So that's our backend stack. So we use AppEngine, we use Golang, and we use BigQuery. BigQuery is a web framework for Golang. It's from China, and for some reason, Golang is really popular in China. So big companies like Alibaba or Tencent, they use Golang for their web services. So we use BigQuery, and the guy who wrote BigQuery framework also wrote a book, how to make a web framework step by step using Golang. So, and then we also use AngularJS for front end, so the web clients, it's easy to use, and you start to see the single page application. And for the build tools, we use Grunt. Grunt is kind of like Maven or Make tools for JavaScript. So you can compile your JavaScript and concatenate minifications. And we use /CSS, that's a CSS preprocessor, and we use Twitter Bootstrap. So we can do responsive web design easily. And for database, of course, we use Google Datastore. It's a NoSQL database, and you can easily use it through AppEngine. So this is our previous stack. You can see this, we replace LAMP stack with our AppEngine. And for the database, we use Google Datastore, and we connect to the recommendation system, which will be explained later. And then we attend Google Devfest last year here. And I think it was Jerome or Jens, and he talked about Google Startup Package. So Google has a program for small startups. So if you are small startups, maybe like less than 20 people or without big funding yet, you can apply for this package, and you could get up to $20,000 credits, which is quite a lot. So last June, we managed to get one. So suddenly we have the credits to try Google Compute Engine. Because if you use AppEngine, you get free tire, so you can try without having to enter your credit card. But in order to use Compute Engine back then, you have to pay. So now we have the credits, so we decided to try Compute Engine. So I'm a Node.js guy, so I feel more productive using the tools that I'm familiar with. AppEngine is Go experience really good. I love it. But back then, there wasn't not so much libraries available, like database or doing authentications and for the front server. So I feel like I'm familiar with Node.js, so let's try it. So that's another reason is to do full stack development using JavaScript. So in theory, you could share code between the front end and the back end. So that's also the benefit using Node.js. And so using Compute Engine, it's the infrastructure as a service. So basically, you can install anything you want. So from Ruby on Rails, PHP, Java. So and Google also have click to deploy templates. So it's exactly what it is. You click to deploy PHP or WordPress or Apache Cassandra. So they have a lot of templates where you can one click and you deploy an instance in Compute Engine. So you can check it out and see how many templates, and it's growing. The bad things that you have to setting up things manually. That's if you use infrastructure as a service, you have the freedom, but you have to take care of everything for yourself. Back then, we didn't have managed VM. Managed VM is pretty new, I think a couple of months ago. So Google tried to build something in between. So it's between AppEngine, platform as a service, and also you get the flexibility in Compute Engine. So you can install anything in this small instance, but Google will host it automatically. So I think, yeah, we can talk about the managed VM later. So this is the current stack on Compute Engine. So we use Compute Engine and Node.JS. We also use Kraken.js. Anybody knows about Kraken.js? So it's an open source web framework from PayPal. So PayPal has, they did port some of their components to Node.js a couple of months ago, and they open sourced the web framework. So, and for the front end, we switch from Angular to Backbone Marionette because Angular is really nice, but we had problems sharing codes between server and the backend. So at the moment, we switch back to Backbone. It's a small library, but you can integrate with many things. So, and for the build tools, we use the same with additional browserify, so you can share the codes between front end and the back end. For database, we use Google Datastore and cloud storage. Cloud storage is kind of like buckets in Amazon, where you can upload your media files and host it as well. And we also use Compute Engine with Docker for our graph database, which Astrid will explain later. So this is the current Twindly stack. So we have Compute Engine server, and we switch from AppEngine to Compute Engine. We have Node.js, Nginx, and PM2 is a process management for Node.js to make sure if the server down, it will automatically restart or upgrade. And you can see the Datastore and cloud storage here. And the nice thing about the Datastore and cloud storage, they also have APIs in Node.js, so you can easily use it as well. And then the recommendation is still black box, and that part will be explained by Astrid.
Yeah, again, we're still missing the recommendation part of this. And when we say a recommendation, what we kept on looking at lately was this recommendation equals big data. It's always said, like, you know, if you want to have recommender, you have to have big data. So that's why when we got the credits, I got the chance to also have a look at some of these systems on Google. Yeah, BigQuery and Prediction API. Well, but BigQuery is actually more for if you have a lot of data and you need a faster way to query the data, which is not exactly what we need, at least not right now. And well, actually, if you want to know more about BigQuery, I think there's another talk later on. Prediction API is much more interesting to us because that's what Google said as their sort of recommendation engine that you can use. And they have currently, if you try it out for like 6 months, the first 6 months is like 10,000 queries, so for free every day. So we also, I thought like, okay, that's nice, but Prediction API, apart from they also need a lot of data to make it work. They also, I mean, it works something like this. So you put weather data, for instance, of Berlin in the past 10 years or so, Prediction API will then be able to tell you what kind of weather would be in a month from now. Like, sort of you put in like, you know, what would be the weather on the 25th of December 2014. And it could be able to predict like what the data from the one you put before. And for us, it might work for if you want to ask if a user would want to buy a certain product. But the problem is, again, we don't have that much data yet. And same goes for Apache Mahut, which is also it's a recommendation engine. It's a machine learning algorithm. It's an Apache license, and they're better in doing clustering. But still, like, you need a lot of data. So what actually can we do? Like, how can we approach this and still work somehow? So we're going down and kind of like thinking, what's the minimum viable recommendation that we can use? So basically, this is what we want to approach in the beginning. So for instance, there's 3 people, Anna, Julie, and Sam, and they're both friends. Anna is friends with Julie, Julie is a friend of Sam, and maybe we want to recommend if, you know, Anna and Sam would like to be friends. Apparently, they also like the same kind of lipstick. Or since Anna likes this eyeshadow palette and like the lipstick, maybe Julie wants to know if she would be liking the lipstick as well, especially since Anna and Julie are friends, you know. So based on this kind of notion that, you know, it should be easy to get who's a friend of friends and what kind of things that my friends like or what kind of other things that they like, if you like a certain item, we start going into graph database. I mean, give and take, you can also get this from SQL. I mean, basically you can model anything, right? Like you can model stuff in SQL or NoSQL, but as you see in our use case, I think the graph database is the best solution because it's shorten the queries and and Gremlin is also a very nice traversal algorithm for graph. So you can also get recommendation from graph, like simple and easy. And that is why we look into these 2 technology right now, RNDB and Neo4j. Those 2 are, I mean, it's slightly different. Like RNDB is a hybrid. They say it's a hybrid between graph and DocumentDB, and Neo4j is a pure graph. They each claim they are better than each other, but you know, like, you can't. You just have to try it out yourself. But it seems to me like, or from the data they have on the site, that it's been proven that they can handle a lot of data. So that's, I think both are okay. The only thing is that we currently use RNDB because of licensing reasons. I think RNDB is MIT or Apache. But the thing is, both of them have limited available library. I mean, graph database is still comparatively young compared to SQL or NoSQL, and Google doesn't have yet like their implementation of graphs. So hint, hint, if someone's listening. And that is another reason why we go back to Node.js, because there's no API for Go to connect to graph. And if we were to use Go, then we have to code our own API. Like, you know, 2 people, not enough time, so let's just try it out, build something that is already based on what other people already done. So then we deploy RNDB using Docker on a Google Compute Engine. Yeah. So here's our current Twindly stack. then now we have like 2 compute engine instances, one for the web client and one for the recommendation system / database, which is, we have RDB and Docker with Docker there. Yeah. So what's next? It's currently working, yeah. We wanted to put in Polymer, introduce Polymer to our system because I do like the look of material design.
They're going to have like introduction
Yeah.
for Polymer today.
Yeah, and also manage PM and Node.JS. And most importantly, like also with a container engine, I think it's just released like a couple of weeks ago, and because we're using Docker, and we want to see like how it could work with the scaling with container engine. Yeah.
I think there will be also a talk today.
Yeah, and there will be a talk today later on in the afternoon with Jens about the container engine and Kubernetes and Docker. That will be very interesting. Cool. So that's the talk. So if you have questions.
How does Docker fit in? Like what? And are you gonna replace Docker with the container to do the container stuff?
So that's also a possibility. That's why I'm looking forward for the Google Container Engine, because right now, in theory, we can also use Docker for our Node.js, but this is steps that, so we Dockerize our ONDB. Maybe later on we can do it for web server, and maybe the container engine could do the auto-scaling for us. That's the things that we're looking forward as well.
How many users have you in your database or user database, and how many concurrent users can you handling right now without adapting?
So right now we're still in close alpha testing, so we have like, I don't know, maybe 40 users for testing. So we haven't tested the upper limit yet, but the database, for example, the ONDB, they claim they could have like million queries in concurrence. So we have to test how's the upper limit.
Any question?
My question was more about, so if you have real users, how many of the credits did you spend? But if you say you are still in beta or in alpha phase, that's maybe not the question of how many of these credits you have already spent.
If you're interested, we can also tell like how much we spent for like the 2 compute engines, and currently it's like
Up to 70?
Yeah, up to 70, 80 euros, but we're
This is,
per month, yeah.
but this is not this is really not optimized because it's development phase. So sometimes we just try to do some stress tests. We fire up instance to test this and that and to see the concurrent. So because we have the credits, we didn't talk about optimizing the cloud, which is not the real case. If you don't have credits, you start to think about, should we just fire up instance, so we just share on the same instance. That's why I think the AppEngine is really nice to get started with, because you even though you don't have free credits, there's a free tier for AppEngine, which you can start using.
Any other questions?
So as we have in our own company this Google developer package too, it's like we spend a lot on the credits for support for this. So how do you do this to ask Google guys if there's anything, I don't know, new, or if you can get beta access to some of these things, do you use this, or is it like you try out and find some more insight in the community, or is it that you ask Google guys for help?
So, for example, the managed VM is really new. So, we applied to get the access, and we got it. And it's very early, so there's a lot of problems. So we're lucky to meet some guys from Google. So we asked them, is this going to be released soon? How long it will take to go beta or even release candidate? That's one. So, and the next step, we check the Google discussion how to do this, and there's sometimes there's not enough documentation how to do certain tasks. So we just have to try and then see the community, and it's quite helpful community there. So you can ask question and people will answer that. Any other question?
So you briefly mentioned Google Datastore, which is like a NoSQL engine by Google. To what open source NoSQL solution could you compare it? Is it like MongoDB, Redis, or completely something else, or is it not comparable at all?
Maybe a little bit like Apache Redis on. I use MongoDB a lot and a little bit Redis, but Datastore it's key value that NoSQL data basically. So they have like basic data type, and I cannot compare it with MongoDB. I mean MongoDB stores stuff and you can retrieve it as a JSON, but in Google Datastore you store key value and you have this basic types. So maybe similar to Redis, I'm not really sure.
Any other question? No? All right, well, thank you so much, Astrid, and
Well, if you are interested in the slide, we're gonna put it up on SlideShare, I think. Yeah. Everywhere my it's always the Twitter account. You can find me on Google Plus or SlideShare. Everything is always Astrid Paramita. Okay. So if I'll upload this on SlideShare. It's my always Astrid Paramita everywhere. Facebook, Google Plus, Twitter, .com. Yes. Okay. Thank you so much for coming.